last session in the flood risk management webinar series, the Watershed University has partnered with the California Silver Jackets Collaborative Flood Risk Program to host this webinar series. My name is Samson Haile Selassie. I work with the California Department of Water Resources, and I'm the State Deputy Lead for the California Silver Jackets, of which we'll hear more later on today. So these webinar series are part of the California Silver Jackets post-wildfire flood education project. The project facilitates outreach for communities about flood after fire risks in support of their efforts to prevent and reduce risk of post-fire flooding and to build resiliency against flood after fire. Over the past 3 webinars, we invited several local, state, and federal agencies to participate in the webinars and share useful information from their experiences in post-fire flood risk management. Next slide, please. So the chart shows the typical disaster flood risk management life cycle with its 4 phases: preparedness, response, recovery, and mitigation. The previous webinars in April, June, and July were focused on 3 of those: preparedness, response, and mitigation. And today, the final webinar is themed on recovery in the flood risk management life cycle. So oftentimes in disaster related public discourse, what's given high coverage is, and what's given publicity as it should be, especially during and the aftermath, is the emergency response and the urgency to save lives and properties. And then after all the temporary repairs are in place, sandbags are installed, the shelter tents are put up, and also the news cameras are gone, communities have to turn their attention to recovery, dealing with challenges associated with rebuilding infrastructure, sewers, pipelines, facilities, and getting the mechanisms and funds for this. Ability to recover typically is driven by 2 things: planning for and building resiliency against disasters, and also implementing disaster recovery plans and getting funds aside for those. Various agencies, FEMA, for example, has community assistance programs to help with raising homes, etc. The Army Corps had the PLA 499 program, which helps eligible local communities in bringing flood control infrastructure to pre-flood conditions. And several communities prepare disaster recovery plans. And today we're fortunate to have a presentation where the importance of technical analysis is highlighted. The urgent need for technical assistance is supporting and guiding decision makers on near-term and short-term recovery options are discussed. And okay, the next slide shows the program for today's webinar. Today's feature presentation will be provided by the Sacramento District of the USAC on modeling debris flow. And also, as we've done at each of the previous webinars, there will be a brief overview of the Silver Jackets program. But first, we'll begin with a brief flood after fire resource pool. And if time allows, we'll have an opportunity for questions and answers before wrapping up and concluding at 12:30. And now I'll hand it over to Rachel Oriana, the California Silver Jackets lead coordinator, to get us started with the flood after fire resources pool, and also for the Silver Jackets overview. Rachel.
Excellent. Thank you so much. I'm really excited for today's presentation from Kelly. I was thrilled that she was able to present, and I'm really looking forward to it. I'm going to go ahead and open a poll. Sorry. There we go. Okay, the poll should be appearing for you now. This is one of my first polls that I'm hosting myself. So over in the lower right corner of your screen, you should see 3 dots. And when you click there, if you click on polling, it will open the poll. So this is a very interesting poll question. I mean, there are so many resources listed here. So it's basically one question. I'm going to narrate it for those who are just on the line and doing so. So it's asking, what flood after fire resources are you familiar with? And there is a list here that is really impressive and comprehensive of all of the different areas that have excellent resources available. And we're going to be sending this list out after this call. But there's resources from California Geologic Survey, from the Silver Jackets program, resources that we've put together, both a flood after fire guide as well as a flood after fire toolkit, and we'll be sharing those links with you as well. The California Flood After Fire, CAL FIRE website, Cal OES, excellent resources listed here, some FEMA resources, some NRCS resources, and so also USDA, NRCS, and USGS. And we're just interested to know, who's familiar with which resources. I see a lot of the results are working on coming in. We've got 13 folks that have already finished, 14 folks have finished the poll, and a couple more are on the way. 18 folks working on that poll and have completed it already, so that's excellent. Just looking to get a sense of what resources folks are most aware of. And then also just, I think asking the question gets these excellent resources on everyone's radar, which is wonderful. Okay, so I will give you a minute more to go ahead and get those answers in. I see a lot of people are familiar with FEMA's flood insurance program. That's really great to hear. And I'm just so thrilled that we have 40 folks on the line here from a really wide variety of different agencies. We have EPA, DWR, FEMA, California Geologic Survey, North Coast Water Board. Such an excellent turnout here. Some local flood control districts. Just a wonderful, wonderful, diverse group of attendees that we have here on the line. All right, great. I'm going to go ahead and close the poll. And it's giving folks 13 more seconds to just get in your last responses there before this closes all the way out. All right, wonderful. Okay. I know folks on the line that are with different agencies are probably interested in knowing, how many people are familiar with the resources from their particular agency. So I have shared the results with everyone, so you're welcome to take a look. And it looks like the resources folks are most familiar with are the Cal OES hazard mitigation grants. We've got a lot of folks familiar with that, as well as the FEMA resources. So excellent job, FEMA and Cal OES, getting the word out about those excellent resources. All right, and we're going to go ahead and go back. I'm going to share just a little bit about Silver Jackets, and we'll be turning it over to Kelly for her presentation here today. And Kelly, am I in presentation mode? Does my presentation look?
You are. Yep.
Just wanted to double check. All right. So I wanted to provide just a brief overview of Silver Jackets for those on the line who may be logging on for the first time. I know a big presentation like this on flood after fire can draw in folks who may not have heard of Silver Jackets. And so we wanted to share great information with all of you. So Silver Jackets is an interagency program focused on reducing flood risk. These teams are state-led, and a lot of what that means is that we brainstorm ideas throughout the entire year, and we really look to our state partners to prioritize what projects the team will be working on for the following year. So that is how this webinar came to you today, is that last year when we talked to our Silver Jackets leads, they said, you know what, we could really use more education and outreach and support around flood after fire. So we took it on to take experts from a variety of different agencies to bring this webinar series to you. So these Silver Jackets teams develop these interagency proposals, And they're usually 12 to 18 months, and we look for contributions from all of our partners, like those agencies that are here on the line with us today. And we provide support through the entire flood risk management lifecycle, as was spoken about earlier. And so this is just a great opportunity to provide some continuity of support through the whole lifecycle. And these projects help us to move along the collaboration continuum. So often we find when we're first working with an agency, each agency really is focused on their own individual efforts and mission and processes. And there can be a lot of coexistence, self-reliance, and these projects give us a chance to start communicating where we're sharing information. They get these partners working together when it's outside of an emergency to share resources and working together on the project. We're collaborating, we're sharing work, and ultimately sharing responsibility. Moving along the collaboration continuum, it doesn't just happen with one project. It's often projects that build off of each other. And so, developing the Flood After Fire guide that was intended for a public audience then helped us to build off of that and develop resources that were for a technical team, also helped to, connect us with the folks that led to some of the efforts that Kelly's going to be talking about here today. And so these projects really do build off of each other, and Flood After Fire is a great example of one area where these efforts have really piggyback off of each other, leading to more shared responsibility ultimately. So some examples of the interagency projects that have been developed by the Silver Jackets team. We can do floodplain mapping and hazard assessments. We can do emergency action planning, developing either step-by-step guides, hosting workshops to help communities that want some support on their emergency action plan and they're not sure where to start. We can provide a roadmap for that, and we have a guidebook, and we can do a workshop. We can also help communities and hold their hand one by one and assist them in developing those emergency action plans. We can develop education and outreach resources, including, here's one example. We developed these door hangers for Mesa County in Spanish and helped get the word out about flood risk. We've also developed some coloring books. As I've mentioned, we've put in the Flood After Fire California Toolkit, which was designed for a technical audience for GIS experts, hydraulic engineers, as well as hydrologists. A technical toolkit with excellent Flood After Fire resources is great to know about. And then we also have a Flood After Fire guide for California communities that we've put together as well. And we'll be emailing these out along with the list of all of the resources as part of the follow-up after this webinar here today. Through Silver Jackets, we can also provide support to communities in better understanding the community rating system and customize support of how they can improve their scores in the community rating system. And we can provide planning studies and watershed assessments, helping to understand water resource problems and opportunities, determining measures that can reduce the problems and identify partnerships for collaboratively working together to reduce that flood risk. So if you have any questions, please do email me. I'll put my email in the chat. You're also welcome to put any questions or immediate comments into the chat, and I'll be monitoring that here as well. So with that, I'm going to go ahead and turn it over to Kelly for her presentation here today.
Awesome. Thanks, Rachel. Let me just get my screen set up a second.
And I just want to say how excited I am for Kelly's presentation. So as the Utah and the California Silver Jackets lead, as well as Nevada and Utah, and one of the efforts that Kelly's going to be talking about was in Utah, where our Utah state partners called and were like panicked that, one of the communities was getting National Weather Service was saying the run-of-the-mill thunderstorm was going to potentially have debris flows going into people's backyards. And they're like, what kind of assistance can you provide? And I was so relieved that Kelly raised her hand and stepped forward and was able to provide some really amazing support. And I've heard a little bit about it before, and I'm really excited for this presentation that she's going to share. Over to you, Kelly.
Awesome. Thanks, Rachel. Yeah, I appreciate your encouragement and enthusiasm for this work because I feel the same way about it too. Is my screen share looking good and can you hear me okay?
Yep, I can hear you great and the screen looks good.
Awesome. We achieved technology success. Wonderful. Okay, well, I just wanted to start by saying, I guess, good morning, almost good afternoon. My name is Kelly Jeames, and I'm a hydraulic engineer in the Sacramento District Office of the U.S. Army Corps of Engineers. So my day-to-day role is primarily technically focused, and I spend a lot of my time working in our HEC-RAS hydraulic modeling software that's developed by the Corps Hydrologic Engineering Center, which I'd imagine a number of you are familiar with on this call, but I'll also try to keep this talk out of the technical weeds, but offer a few pieces of technical information for those of you that may be interested in it. So the name of my presentation today, which has been adapted from many other presentations that Rachel has seen parts of, but today it's called Modeling Debris Flows in HEC-RAS to Diverse Applications. So I'll provide just a brief introduction on what I plan to talk about in this presentation. So just to provide a definition, debris flows are a dangerous and destructive geologic process that can transport large volumes of debris, which might be sediment, boulders, trees, cars. A number of you, I'd imagine, have seen pictures from debris flow events that have happened over the years and decades. And debris flows are typically exacerbated by post-fire conditions. So when a watershed experiences a fire, it may lose its vegetation cover or other changes to the soil, like becoming less repellent or more repellent to water. Infiltration can make debris flows a larger issue and more dangerous and destructive than they already are. But on the technical side, modeling a debris flow has been a bit of a limitation in currently available software, especially publicly available software. So up until around the year 2020, the HEC-RAS software included the ability to model what we're calling non-Newtonian, and I'll get to that in a second, but debris flows. And this is a new feature that we quickly took advantage of, and I'll be sharing two applications of this modeling software, one for a community planning study that took place in Colorado, and then an emergency post-wildfire inundation mapping effort that took place in Utah. All right, so just to provide a little background and context on maybe some of the technical terms that I'm using is just a bit of an understanding about debris flows and how they work. So as the concentration of debris within water increases, the fluid behaves under the assumptions of non-Newtonian physics. I understand that statement might be a little scary, but if you can trust me that water is a Newtonian fluid, meaning it functions under its own set of properties and things you've experienced. When you fill a cup of water, it runs out and it keeps flowing until there's not enough slope to keep it moving, or it runs into something otherwise. Now, if you'd believe me when I say that debris flows function differently than clear water flows, I think we all kind of have an experience where we could say that that's true. And that's the inherent issue in modeling debris flows with traditional modeling approaches, is it really doesn't capture this different physical process that's happening. And that's where the need to be able to model these processes in a different way was really apparent. Like I'm saying, there's just a huge limitation in properly capturing inundation depth and runout when you're using traditional clear water modeling approaches. And I want to highlight kind of the benefit that this modeling software has provided in being able to give accurate solutions, which ultimately allow us to accurately implement post-fire recovery. And some of those tools that come out of that would be something like inundation maps, planning evacuation routes, identifying at-risk infrastructure, modeling intervention methods. So the benefit that being able to properly model a debris flow from a post-fire event, the benefit that it provides really allows us to implement better solutions and help communities recover better. Okay, so I'll get into my examples here of two projects that I directly worked on. The first one being in Ouray, Colorado, which is a beautiful area. It's located in the very steep a mountain range within the Rocky Mountains that is just inherently erosive. It actually hadn't recently experienced a fire, but it just has physical properties in which debris flows occur on a seasonal basis. And these debris flows were threatening a road crossing area that served as a secondary evacuation route for the community. And that was a real threat to public life safety and other utilities like gas lines, communication. So the need to build a more sustainable solution was apparent in this area. This road had been destroyed
The audio cut out for me.
getting a thumbs up. I don't know if that's a positive or affirmative.
Audio's back.
It's back.
Yep, it all sounds good now. And I'm seeing in the chat, folks are saying they can hear you now, and they're letting me know that the audio cut out for them as well. So thanks so much. Appreciate everyone sharing with us through technology hiccups. Thank you, Kelly. Back over to you.
All right. Don't know why, but I have coverage and internet and all the connections I thought I needed. But I was saying, if you look at the top photo, that's kind of the sunny day condition of this area, and the bottom photo is what a debris flow aftermath can look like. So we're talking about significant damage, significant amounts of material being transported. So I'll just go through kind of the modeling approach that we took and do a comparison. So the top image is an inundation map from Clearwater modeling alone. The bottom image is one from our debris flow modeling. And if you can pay attention to the legend that has the depth, on the top image along the road, which is the white line, you're seeing our models only estimating a depth of about 0 to 2 feet, when in reality we knew, and from the picture you just saw, there's a lot more than 0 to 2 feet worth of material deposited on the road. And our legend for the debris flow inundation depth is showing it in the range of 6 to 15 feet. And so I think this really clearly paints the picture of how much the different modeling approach really better captures what happened in reality. And that offers huge benefit to the community in being able to appropriately size culvert structures or plan different, solutions, road routings, things of that sort. So just to touch a little bit on how we did this. So we went out and surveyed tree scour marks, which was how high the debris depth had reached on trees. So the bark where it's been worn off these trees is from the flow of that debris rock slurry. And so we went and surveyed these marks and used them to calibrate the model. So red dots represent areas where a surveyed scour mark was collected. And then in the bottom plot, the profile, you can see the orange line represents the depths of two different debris flow events. And we're seeing that our calibrated results really land within those measured scour marks. Whereas if you were to plot the Clearwater flow alone, it would be much, much shallower. And we knew that that didn't represent what has happened in reality. So kind of just a test case here for a well-performing model. And the application of this really kind of the recovery piece and what it was used for to help this community was we were able to take this study into modeling, I think where we have 5 different alternatives. So we modeled different box culvert configurations, embankments to contain flow to the channel, bridge configurations. And so that picture on the bottom is kind of an example of the multiple box culvert solution that we proposed and ultimately ended up recommending to the community. And the hydrograph on the top is, again, just a comparison of Clearwater versus debris flow. And you can see the difference in peaks is about 150 CFS. So again, if we were sizing our culvert based on the Clearwater hydrograph, we're missing a huge portion of volume and magnitude that would otherwise, you know, our design wouldn't be the appropriate size if we use that Clearwater flow. So that's where the debris flow modeling really provided benefit in getting an appropriately sized solution for this community. All right, and then next I'll shift gears into kind of the second application, which is on the other side of, kind of the other end of the spectrum, where the Colorado study was more of a long-term study, whereas Mapleton, Utah was an emergency response effort. And this is directly related to a post-fire event. So just a little background on it. In October of 2020, this community experienced a fire that burned about 900 acres in a steep drainage immediately upstream of a housing development. Following this fire, the different teams performed their analysis, including the USGS with their debris hazard mapping, and they came in and said that there was a high likelihood of a debris flow event occurring post-fire with, you know, moderate summer thunderstorms occurring. So that raised a huge flag in the community of being at risk, pretty much imminent risk of experiencing a debris flow. And this is what Rachel was talking about of through the Silver Jackets team reaching out to the Army Corps. We went through our Public Law 8499 program in order to provide advanced measures, technical assistance to this community in a very short time frame. And so one of the outcomes of that analysis was for us to evaluate placement of flood barriers and develop inundation maps using the same debris flow modeling approach. So just to provide an example of what that map ended up looking like. So on the right side of the map is kind of a zoomed out view, and the range of red, yellow, and orange colors is showing the USGS estimated debris flow probability. So you can see in the larger watershed, that's the Ether Hollow watershed, that's kind of that dark maroon color. The USGS predicted an 80 to 100% chance of experiencing a debris flow event for a certain precipitation, but event that was fairly likely to occur. And without being able to do debris flow modeling, we could have produced a Clearwater inundation map, but it really wouldn't have shown the runout depth and extent like we were able to capture in the debris flow modeling. So on the right side is kind of the zoomed in debris runout fan that they could expect to see out of this drainage. And they also didn't have inundation maps produced for this drainage otherwise. So this was really a necessary effort. They didn't have any idea of what flooding or debris flow could look like coming out of this drainage. And then you can see highlighted are the blue affected buildings, which helped the community get an understanding of how many houses were at risk and maybe who didn't need to be as concerned as they previously thought they were. And so I'll get into a little bit here of kind of the laundry list of response efforts that this community made. They really did go through a lot of effort to inform the community. They did that through community meetings, flyers, banners, door-to-door outreach, an Everbridge emergency alert system, and they ultimately formed an evacuation group message for those houses that were identified to be within the immediate potential affected area. And I'll skip down to the third point. Kind of the highlight of this study was prior to the inundation maps being developed, that group message had about 70 homes worth of people on pre-evacuation notice. So anytime it rained all summer long, everyone from those homes felt they needed to either be ready to evacuate or evacuate, which was a lot of burden on them, especially because after developing the inundation maps, that area was reduced down to only about 20 homes that were really in immediate risk of being affected by a debris flow. And so this helped the emergency responders not have to be in harm's way if they were going door to door to impose an evacuation order. It really helped get that community evacuation group smaller and ultimately have a more efficient evacuation. And they did evacuate twice, I believe, over the course of the summer, and they did experience a small magnitude debris flow, but everyone had been out of harm's way for it, and there was really no major damage and no loss of life in that event. A couple other things that the community did was install a burn scar weather station to help with that rainfall monitoring. So having a quick sense of how much rain was falling on the burn scar and if they should be issuing evacuation orders or notices. And then the pictures on this slide show the community sandbag filling event and placement that everyone participated in. So they were able to get the resources together to fill sandbags, and then had a good amount of community participation to help them place them at areas that were identified to be at risk within the community. And those areas were also they were guided by the inundation maps that we produced. All right, so just a quick comparison of these two different models and studies was just looking at two totally different watershed conditions. One in Colorado, like I mentioned, had not recently experienced a fire, but was just highly erosive by nature. In Utah, they had recently experienced a fire, otherwise hadn't had debris flow issues. Both are small scale, but Mapleton was a lot smaller than Colorado. In Ouray, you saw we did a pretty detailed calibration effort with measured scour marks and historical observations, where Mapleton was done on a very quick time frame, so we really only had time for a sensitivity testing level of calibration. For the project time frame, the Colorado study was about 2 years from start to finish, and the Mapleton effort was about 2 weeks total from us receiving the call, going on a site visit, returning, and delivering inundation maps in about a 2-week time frame. And in both cases, we produced inundation maps, but in Colorado, there was a full-blown alternatives analysis with conceptual design, and on the Utah side, it was just emergency inundation maps and a brief evaluation of where to place flood barriers. All right, so to conclude, modeling non-Newtonian debris flows, at least in my experience in HEC-RAS, has many diverse applications and is a very useful tool for post-fire recovery. It can really be scaled based on project timeframe, desired level of detail, and how much error you can tolerate in your results. If it's an emergency effort, you can produce a map in 2 weeks. You can produce it in a couple days if you have all the data you need. And you can also really scale it up and use it for detailed studies where you need to model different structures and alternatives, and, given time and money and available data, you can get pretty detailed with the HEC-RAS model if you so desire. So I think really the main takeaway for me is that this is very applicable for studies ranging from emergency response all the way to conceptual planning, and those both really offer huge benefits for communities looking to plan for either immediate post-fire effects that they're feeling, something that they need a quick response to help inform, recovery decisions. And it can be used for long-term planning or hypothetical too. It could be looking at what a debris flow might look like if the community were to experience a fire. So it doesn't necessarily have to be a situation where a fire has occurred. And I think that holds great value for communities trying to be proactive, and also ones that have to react to a situation where they've already experienced a fire. So I hope that provides just an idea of what is possible on the technical side for helping evaluate conditions and just present better solutions for post-fire recovery for communities. And with that, I will open it up for any questions or comments. And I know, Rachel, you wanted to do other discussion. I'm not sure if you want questions now part of this or like a combined conversation. We can keep them focused on the presentation if you'd like.
Yeah, I think starting with being focused on the presentation is great. And I know we've got some excellent representation here. So I'm just really interested, I'm curious in hearing folks' responses to the modeling that you're sharing. I just want to say how much I love the concrete applications and like the photos that like I feel like help make this accessible and understandable to everybody. Like, I feel like this is an area that can be really challenging. A lot of folks on the line are communicators trying to bridge the gap between like technical work and like helping understand what's the impact, why is it important, why does this make a difference? And so, you know, I felt like your photos and very concrete examples showing the hydraulic modeling, the way that you calibrated, the impact. I mean, I think I personally, since I was very much interacting with the community that was needing to evacuate 70 people every time there was forecasted water, and then to be able to see the difference that it made, to then have it scaled back and only have it be 20 people. And then the concrete change that like when there was, you know, some debris flow that happened, that people were getting out of harm's way. And, you know, thankfully the impacts were limited. It was huge. And so I just really want to say how much I appreciate you articulating that and helping to bridge this gap. I see Frank, who's a fellow communicator, came on there and was, I don't know if Frank, you wanted to chime in. I know, you know, bridging this gap between understanding the technology and the hydraulic model and sort of those applications, it's a challenge that I imagine you face as well.
If anybody has a poor sense of timing, it's me, because I saw most of the presentation. I had to drop off for a quick call and I rejoined you. So the premise was, if you could just repeat it, Rachel, I'll see if I can chime in again. Hang on.
Yeah,
Go ahead.
no, I'm sure there's others that are in that same boat as well. So basically, you know, what Kelly was highlighting here is she was giving two very concrete, specific examples of how a hydraulic debris flow model was used in order to assist a community. And they were, you know, two different communities. One was sort of more longer term planning and one was immediate flood after fire response. And so she just helped to connect the technical work, the hydraulic modeling and mapping, and how that, she helped us to really see how that information was helpful in the moment. And so anyhow, you're welcome to chime in if you have something to say, but you're also, I know that, you know, that sense of like coming in sort of halfway through, and it was a good reminder to just make sure to recap for those who might have called in partway through to recap some of the key points.
Yeah, well, I only dropped for about 5 minutes, so I caught most of your presentation. Two issues come to mind. I think one was, of course, the Thomas Fire and how the debris flow maps were designed for Santa Barbara County in the Montecito area. And that not only helped the community in the change their planning guides, their ordinances, so that they could take the advisory maps and make them appropriate for their permitting. It was also used for a grant that they received. I think it was a $13 million FEMA grant to build detention basins. So there was a lot of benefit from that, not only immediately, but down the road on the resilience side. And these don't automatically happen, but there is certainly benefit to planning and future permitting.
Excellent point. Thank you, Frank.
Yeah, and I would say the Montecito fires are what got this modeling off the ground, at least at the HEC. So that was like the very first debris modeling that was done was in Montecito. And they really saw the benefit of, you know, how different the Clearwater map was from the debris flow, and, you know, it really warranted some updates to how things could pan out. So yeah, I hear you on that one. I'm going to stop sharing so I can get to the chat and look at some of the questions that were coming there. All right, so I'll start with Don's question. Did you conduct the hydraulic modeling using LIDAR? Yes, in both cases. Thankfully, the state of Utah has quite an extensive collection of LIDAR publicly available, so we used that. And then for the Array project, we had it within the budget to collect LIDAR for that study. It is inherently challenging, though, because with the debris flows, the landscape is changing pretty quickly. So between the time you may have collected that data and you get to modeling it, it could be completely different. So there's some error associated with that, not using the most current conditions when you get around to your modeling. And then I'm going to summarize a couple, I think, here. I'll hit on the one about how HEC-RAS models non-Newtonian debris flow differently than Clearwater. So on a technical level, the way that the models address kind of this non-Newtonian physics aspect is by adding new loss terms within the momentum equation that's used to calculate debris or water depth. So simplistically, it just adds essentially friction slope terms that, like your Manning then, would normally be the one component of losses within your model. That's kind of, as hydraulic modelers know, like the catch-all for your uncertainty of roughness associated with the ground and other things you can't account for, like steepness of the terrain. We have a couple other terms to account for like internal yield strength within the like debris matrix, and viscosity is kind of the other physical parameter to define, to make that fluid different from water. So you have a higher viscosity than water and an internal yield strength, which water does not have. So those kind of make that fluid different than water in the model. And then the computation is all using the same computation used in a Clearwater modeling sense. I hope that is answering your question, not making it worse. But that's kind of the level of understanding that I have and can explain it on. And I'll hit on Don's question again about how to bulk Clearwater hydrograph to account for sediment. And that's kind of the direct or a different approach where like the RAS modeling is not, it's actually modeling that debris rather than having to just take Clearwater and maybe multiply it by a factor. There are a ton of other tools, and I think that's where the different resource agencies can provide all kinds of different approaches to estimating like how much we think that debris may contribute to the overall volume of a flow that you could see. HMS, and if I had more time, did a different presentation, we could talk a whole nother amount of time about the HEC HMS software that has the ability to come up with sediment yield estimates using, I think it's 5 different methods at this point. There's 2 from the USGS that have been incorporated, 2 from the LA district that are pretty standard of practice in California, at least in my experience so far that I've seen. So those give kind of a different side of understanding this debris flow problem in the form of estimating sediment yields. But how to go about bulking Clearwater hydrographs, again, it's really case by case, and I think you could look at the whole range of different approaches and, you know, average them, pick the highest, lowest, middle ground, depending on kind of what your circumstance might be. And I do want to get back to the question about what would be the process to request this type of modeling, cost, time frame, et cetera? Does a site survey need to be done? I would say you definitely need some form of terrain data that preferably LiDAR that's like of a decent resolution, maybe like 3 meter maximum. Like having a high resolution terrain data is really important for having an accurate hydraulic model, and you need an accurate hydraulic model in order to produce an accurate debris flow model. So that'd be a big data need and a cost driver potentially. Without survey data, you really can't, or without a terrain surface, you really can't develop a very accurate model in this type of situation. The request for this type of modeling, at least on the Corps side, is dependent, like what we talked about. We went through the PL 8499 program that gets prompted when communities kind of reach their end of their ability to respond, and they go up through their county potentially, and then through state, and then they come to the Army Corps to request our assistance. But the other thing is that HEC-RAS is a publicly available software for everyone, free to download. So anyone that has the capability, or like an engineer on staff that is capable of using this software, has the ability to develop this type of mapping and do this analysis. And yeah, I see Rachel, if you want to add anything to how these things come about, feel free to take it away.
Yeah, I'm going to chime in there. So we actually have some sort of hot off the press updates that I think are exciting about our ability to provide particularly support to economically disadvantaged communities. Our Planning Assistance to States program has announced a cost share waiver to communities that are economically disadvantaged. And so that's an excellent way to get some support, and that could include this type of debris flow modeling. Also through our, we have through the Floodplain Management Services Authority, we also have an ability to provide support to communities at 100% federally funded effort. So when Kelly was talking about the URE support that she provided, it was through that avenue. And so that is a support. It's more long-term planning support. So definitely for something that's happening urgently, the type of time frame that Kelly was talking about, where if that something got done in a couple of weeks or a month, I think it was like 6 weeks or 2 months from the time we got the call to the time all the work was done. It was incredibly prompt. And for that, it would be through our PL 8499 program, as Kelly was saying, when state resources have been exhausted, local resources are exhausted, state resources exhausted, and they're reaching out to the federal government for assistance. And so that is definitely the case for that type of really prompt, fast support. But for that more long-term planning, where you have time, maybe something has happened, you want to do a better job of planning for the future. Army Corps of Engineers has some good federally funded opportunities to be able to provide some support. Also, one other plug for assistance, there is currently, for the first time that I've ever been there, our Continuing Authorities program. So this is one of the very unique authorities that has the ability to help a community all the way through implementation. So everything we've been talking about so far, it's all just planning assistance. But to get a community all the way through implementation, there's currently an opening, a call for proposals through October 20th, where economically disadvantaged communities can have their cost share waiver waived, where it would be fully federally funded. Now, the locals would still need to secure land, and they still need to deal with any hazardous material. And there are definitely some nuances to that program, but it's really worth looking into. If you are from a community that's economically disadvantaged and you need support through implementation, and we are available to assist and help through that application process. So anyways, just wanted to chime in with those additional sort of resources and provide some insights on the timing there as well. I'm just going to go back to the chat and make sure that I covered all of that question. As far as contractual agreements, Army Corps of Engineers, we're not a granting program, and there isn't a contract with us. It's really more of a letter of agreement. And so you're just, a letter of intent requesting it, and then there is an agreement, not a contract, but it is an agreement that we both sign. And the time frame for those, if it's a Silver Jackets project, it's usually 12 to 18 months. If it's a direct FPMS or a PAS project, that could be anywhere from 2 to 5 years. I think Kelly did talk about sort of the topo data, because part of the question was, does a site survey need to be done, or can it be accomplished based on data provided from a jurisdiction? So I think what Kelly was saying is that it's just really important that accurate, high-resolution topographic data is available to inform that hydraulic model. And I think it would really be on a case-by-case basis if a site survey would need to be part of that effort. It would just really depend what topographic data is currently available, how high resolution it is, and probably some of the nuances of the modeling effort that goes along. If there are details that seem like they're making a big impact in the hydraulic model, that might be another reason to get out on the site. But anything you want to elaborate or sort of chime in there, Kelly, about the site survey specifically?
Yeah, I think you hit it on the head, Rachel, and then just a high-level point about it is, I think kind of the point I'm trying to make is that this software and approach is really scalable. So like to the question of cost, time frame, data availability, as long as you have enough topo data to get started, I think you can really scale your effort based on your needs. And yes, the inundation map you produce in 2 weeks is going to have a huge caveat that it reads on it saying this is uncertain, but some information is better than none. So getting that out, and I think this just allows us a way to get information out to a community on a really short time frame. And if you have the time and funding and desire to survey every detailed, structure within your system and things of that sort, then you're very able to add that stuff within HEC-RAS as well. But I think that's one huge benefit of the program is you can keep it really simple and rough and get an answer pretty quickly, or you can go really detailed and in-depth if it's warranted.
Excellent, that's such a good point. And keeping an eye on the time here, just noting that there's just 2 minutes left before we were planning to head over to Samson for some closing remarks. So just one last sort of skim of the chat. If anybody has last questions.
Jamie has a hand up.
Oh, yes, go ahead.
Initially, maybe, if you do,
yeah.
Go ahead.
Hi, I was just going to make a couple quick comments. Jamie with the National Weather Service down in the Oxnard office. And one of the, we've been working hand in hand with the USGS and California Geological Survey on post-wildfire analysis and threshold map or hazard mapping. And one of the things that the USGS, when they do their hazard mapping, they always map the hazard within the burn area. One of the things that was always missing for us was the run out piece of it. And that's one of the things I see with the modeling that you're doing that I'm really excited about is, and I know the USGS has been working on it, but is that run out? That's that's been a missing element for us at the Weather Service, because our warnings and the debris flows don't stop at the burn area boundary. They continue going downstream. And so that's one of the things I really, really like about what you're doing is that run out piece of it. And that would really, really benefit us at the Weather Service. And the other thing that you had mentioned, so at the National Weather Service, we have our watch warning program. So we don't issue evacuations. I mean, that's other agencies take care of the evacuations, but we do flash flood watches and warnings for different burn areas. And we're always cognizant about maybe over warning. So, we draw our polygons and sometimes we tend to be a little more conservative and maybe we are over warning. And so your modeling on that one case, you showed that you went from going from I think you said 70 homes down to 20 homes. I mean, that's the kind of stuff that would really help us at the National Weather Service too, is we're trying to make sure that our warnings cover the appropriate area. We're not, over warning and telling people to evacuate when they really don't necessarily need to. So I just wanted to mention that it looks like really beneficial stuff for the National Weather Service too, and for what we do. So thank you.
Awesome. Thank you so much, Jamie. I really appreciate you chiming in there. It's so helpful to hear from different agencies and understand the applications and sort of like yeah, it's just a rare treat to be able to connect the hydraulic modeling and hearing from a variety of different agencies about how that's applicable and helpful. So thank you, Kelly. That's great. And did you have any last things you wanted to say before we turn it over to Samson for concluding remarks?
No, I just appreciate the feedback from everyone. I guess I will highlight the two links I put in the chat are kind of the HMS side of things that were asked about, but that was another awesome effort based on the Hermit's Peak fire that occurred in New Mexico last summer. The Army Corps undertook a pretty significant watershed modeling effort to support those communities. And then in order to share that information publicly with everyone, we took that direct work we did and essentially made it a tutorial guide that's publicly on the website with all the files you can download. You could basically play at home and do it yourself. But I see that being a huge resource for communities as well. So I'll leave you with that. Thank you, everyone, for having me.
Awesome. That's great. Thank you, Kelly. And over to you, Samson, for concluding remarks.
Thank you, Rachel. And that was an awesome presentation, Kelly. And now we've come to the conclusion of the webinar series in post-fire flood risk management. During those webinars, over the course of the last 4 webinars, we've heard from various local, state, and federal agencies, federal, state, and local experts engaged in preparing and planning for flood after fire disasters, emergency response tasks, post-disaster recovery, and mitigation actions. And as we close this webinar, we want to share 2 important flood after fire resources specific to California. And those were mentioned earlier by Rachel. Those were prepared by the California Silver Jackets in collaboration with multiple agencies. And let's see if I can share those. Rachel would be able to share those. Maybe I'm trying to see.
Yes. Let me. I think that those were all the slides that I had.
Okay. Now just referring to
the wanted me to go back and share the slides.
the flood after fire toolkit. Yes, there it is. So we can share the PDFs for those in the chat. I'm not sure if we are able to do that. I was planning to see if I can share those.
And I think we're planning to email everyone's tracking. We're planning to email the list of resources, and also the links to both of these are going to be coming to all of you in an email, I believe later today or tomorrow, just so that everyone has future reference. Yeah, perfect. So the 2 documents that I was talking about, the first one is the Flood After Fire California Toolkit. It mainly contains, as Rachel mentioned earlier, technical resources that are useful for experienced technical specialists, providing assistance to communities impacted by wildfires and the flood and debris flow that could follow them. The other document is more for community leaders. It's After Wildfire Guide for California Communities. It's a consolidated resource that can help them recover from wildfire and post-fire hazards. And then a quick plug for the California Flood Preparedness Week hosted by DWR is planned for late October, October 21 to 28. It's a series of events and activities where local agencies share information about flood risk and how to prepare for them. So please look out for details. Please check if your community and county is participating. Let me see if I can share that website where we have
information on this. There it is, yeah. So as we get closer to the event week, there'll be more details on activities planned for that week. And finally, I'd like to thank our presenters today, Rachel Oleana and Kelly James. Thank you so much. And thank you everybody for attending. And we especially want to thank those who attended all the 4 webinars in the series. And we look forward to seeing you all in similar workshops and webinars in the future. And as always, we always welcome ideas that you might have on topics for future webinars. Thank you again and have a great rest of the day. Bye.
I see Ken, yeah, has, Ken, would you like to come and speak up? Oh, looks like he just, maybe that was an accidental. Thank you all. This was such a wonderful webinar. I'm going to go ahead and stop the recording and stop the sharing.